So Joe is going to talk about, and thus I'm going to pretend to talk about, how OpenStack has evolved. And apparently he gave this talk previously, and there's actually a YouTube video of it that I could play that was also suggested as a possibility. So if we get a few minutes into this and you decide that really it's not working for you, shout out and we'll switch to the video. So, Joe. However, I am full-time upstream OpenStack. I'm a developer at HB. I'm PTL. I'm on the TC. I'm not Nova Core, but I am core on OOO and review stats. Right, so I love this, it's totally off topic, but I love this presentation software. It's great. So, who here has used OpenStack Diablo? Okay, Essex is listening to me. Sorry, Folsom and Havana, and hasn't used OpenStack at all. Right, well that's actually interesting. About half the room hasn't used OpenStack. So the three of you that have used Diablo will probably get the most out of this talk. Everyone else, be amazed at how much OpenStack has grown. So I'm probably overlapping some of the earlier talks, but I don't know how many people have come in and out of the room, so I'm just going to define everything and make sure there's no confusion. Swift is the object storage layer for OpenStack. You upload individual files, you can download them again later. This is revolutionary technology. The key thing about it is that it scales, so you get a lot of redundancy, you get a lot of performance. It's much, much better than just backing Apache onto NFS or something like that. Nova is a manager for hypervisors, so it can manage KVM or Xen or VMware or what's the Microsoft one? Hyper-V. And there's actually a fairly long list of drivers. In Diablo, there wasn't such a long list of drivers. And in Diablo, Nova did much more than manage hypervisors. It also managed block storage. I think it managed block storage. It certainly went in around there. And it managed the network. So Nova Network was a core part of Nova. And the identity management stuff hadn't really been sorted out. I'm not sure it really has been sorted out yet, but it is a separate project now. And there's this thing called Glance, which is a service for managing disk images. Now the difference between a disk image and an object store is that the disk image has metadata. I love the presentation software. It doesn't mean I'm good at driving it. Essex. Identity really moved out into Keystone, so a lot of the functionality was deleted from Nova with a migration path, I believe. We weren't terribly good at migration paths then. So I guess here's a big difference between Joe and me. Joe was there, he saw this stuff happen. I wasn't. So folk in the room who know more, please correct me so that the video can actually have the right data on it. And Horizon came in, which is the GUI. That was that.
Keystone has a star next to it, which makes me think it wasn't called or something?
So Keystone got completely rewritten from Diablo to Essex, if I remember the timeline correctly. We're actually now running what was technically Keystone Lite. This may seem ironic if you've read base, but not ironic the project, because that's a different code base, which is Lite. So in Essex, the major evolution was to take the identity stuff out of Nova, bring it to a separate code base that can be installed independently. It means you can have it without having hypervisors. That's useful if you start wanting to be able to make it available to people who are just using, for example, object storage. And Horizon, a UI for managing your compute resources that you've deployed into your cloud, was created. Horizon has only just started getting features for managing the cloud itself. Its primary use has been as a better UI for people than running the CLI to drive Nova API. So it's a end user UI, not a admin UI. That's changing. It's becoming both. Folsom, Nova Volume and Nova Network split out into separate projects. Quantum is in brackets Neutron because after a couple of releases, a company who owns the trademark on Quantum realized that there was a another project in the computing space and decided this was inappropriate.
It wasn't on this claim, they were the quantum networking company.
Oh, I always thought it was Seagate with their quantum drives.
No, there was that, their trademark did read right on it.
Okay, so apparently the trademark claim was more than just the same letters, it was actually in the same business space. So, anyway, we had to rename that, and it can be confusing for new players, particularly because there are people out there still running Folsom or Grizzly, which still has a product called Quantum in it, but Quantum in Horizon doesn't exist. So Nova Volume became Cinder, and Nova Network kind of became Quantum. Now, one of the interesting things here is that Quantum didn't bring across all of the functionality of Nova Network. It tackled a bunch of problems that Nova Network had, and that there was nowhere for vendors to really plug things in. But it's not a superset of functionality, it's still not, and that's a contentious point.
Just my understanding of it was that Neutron, and part of the difficulty was is that Neutron was not actually born from Nova Network.
Anyway,
sorry.
The mechanics of it, sure, but the key point is they were solving problems that needed to be solved,
Yes.
but they didn't solve the problem of keeping all the functionality.
Yes.
Neutron was much more aligned around needing a control layer to.
Cinder did keep all the functionality, and Cinder today is not a contentious project, and it does have vendor backends. So there's a bit of soul searching going on amongst the TC and PTLs at the moment, as we think about this to avoid it in future, because there are other things that will need to be split out. And that's why Nova Network is still here in Grizzly as a line-through thing. It's deprecated. It's deprecated in Folsom.
It's not deprecated, it's frozen.
Potato, potato. It's. Thank you for correcting me. I did ask for that. The perception from developers and end users is varied about this. I consider it deprecated because we're telling everyone to go and develop on Neutron.
Right, but yeah.
I don't want to have a debate about it. I'm just saying that's why I'm presenting it the way I'm presenting it.
So this is also about how this has been in production, and not just where we're saying developers, but correct me if I'm wrong, other people in the room might be running this in production. Nova Network was often run in production in Folsom and Grizzly.
Yes, and in fact, it's still, and in Havana, people are still running Nova Network in production. So this is the classic dependency diagram for everything in OpenStack. And this is the unupdated version, so it still refers to Quantum. I don't know if you can make that out. So I don't know why Joe put that in there, because it's attached to the wrong release anyway. We also have to send him a bug report. And so Havana, the most recent release, the numbers here are the number of services, independent server processes that you need to run as an operator from within each component. You need to run a minimum of 4 server processes for Swift. I mean, when you scale out, obviously they get copied onto multiple machines, but same binary. 6 for Nova, 2 for Glance, 1 for Keystone. 4 for Solometer and Heat. They're new projects in Havana. First time, not the first time they existed, the first time they were part of the integrated release. So they are official, blessed, you should be able to get support. Features aren't going to be removed willy-nilly.
Things like MySQL, graph-based, and all the other stuff.
They're not things we produce. And
You need to replace the heck
this talk is about the code in OpenStack. It's not about everything you need to run in OpenStack. So this is the impact we're having on operators. When we split out stuff to separate services, the overhead that people have to face. And I'm meant to be doing the short version of this talk, so I suspect we'll just get into some interesting stuff and then have to stop, but that's okay, at least for me. So here's, this is kind of an interesting comparison. It's like how much stuff has actually been added from a user perspective by Havana versus Diablo. If someone was running Diablo today, like say a public cloud provider, how much of a gap would there be for someone who looks at the Havana documentation on the OpenStack website? And actually, the Web UI Horizon, that's a pretty huge thing. Sophisticated networking, Neutron, that's also pretty huge. Solometer, which does, I didn't define things. Solometer is it's essentially a big store for aggregating metrics coming out of your cloud, both your own instances and the cloud itself. What you do with it is whatever you want to. So some people are doing accounting with it, some people are doing load metrics and sensors, and I've got 10 minutes to go, thank you. Heat is a service orchestration layer, so it's not Chef or Puppet, it's a tool to get you with your Chef or Puppet, but your 500 servers, to get them all glued together in the right shape. So it defines a cluster and passes metadata into the machines. It started off as a re-implementation of Apache CloudFormation, and it's got very strong roots from that design and its architecture. It's got its own API and so on these days. And I think this is just, yeah, it's just everything that wasn't present in Diablo removed. So essentially, if you go back to the original Diablo slide, you'd have seen block storage for Nova and identity in Nova and so on there. So it's not a superset. There's stuff we've deleted out of Diablo is on the way to Havana. It's moved to different places. Right. Okay, yay. Trove, Ironic, Marconi, Savannah. I love our code names. Trove is a database as a service, so MySQL on tap, or whatever proprietary or other open source database you want to plug in a driver for. They've got multiple drivers. The difference between, so an incubated project in OpenStack is a project that exists and has a reasonably stable API, but isn't fully glued into the release process. We look for multiple vendors being involved, a healthy review team, a healthy contributor base, product stability and maturity before we say, hey, this is something end users can depend upon. If someone says, hey, this was a really good idea, we wrote it because we needed to, lots of people are using it, but we're about to fix the API by rewriting the thing, it's not going to get through incubation like that. We're going to say, hey, that's great, finish rewriting the API before we start putting people at it. Ironic is a bare metal hypervisor, so it orchestrates deployment to bare metal and may end up doing some metrics. There's kind of where the border isn't very clearly defined yet. The big benefit from that is that you can use Nova to deploy to physical machines, and that's pretty cool. You can do that with Nova bare metal today, but it's got lots and lots of caveats. Scaling, reliability, performance, which Ironic is solving. Marconi is a message queue as a service. So rather than running up an instance, running up Rabbit inside that instance, and then manually managing that yourself, you have an API to say, hi, I want a queue, I want it persistent or ephemeral, whatever, and the cloud provider then backends that onto whatever messaging infrastructure they choose.
Does that then run up an instance, or it's on the pan?
Well, it may, or it may go multi-tenant. So if you think about it, running up a full VM to get one message queue is really kind of expensive. But asking someone who's already got 5 or 10 servers with lots and lots and lots of queues on them to find space for another queue is very cheap. So it's the whole same value proposition as all of the other virtualization and abstraction that we're doing.
Can you say that again? I don't think that was correct. About what Marconi is doing.
Marconi is
It's a queue, but it's actually doing the queues. It's not provisioning queue services.
I think the way they've chosen to solve it today is to implement a queue themselves. But the point is that it's an API,
Right.
so you don't necessarily know what's behind it from a user perspective. Again, this gets into an alcoholic discussion. And Savannah is big data as a service, so primarily Hadoop, but I know they've got a couple of different vendors in there with slight variations on the build. And they've got an interest in moving to being generic enough to support lots of different big data frameworks. That's where they see their real value sitting. Savannah is currently looking at how it can more heavily reuse heat, because it's basically deploying an orchestrated cluster that happens to be big data. So if they can say, okay, what's our value add over just cluster orchestration, and get away from the huge overlap they have at the moment. I say huge, it's not that big, but it's enough to be worrying. So the existing APIs got bigger, we split out a lot of projects, extensions. So if you look at something like Nova, just at the RESTful API, the RESTful API is pretty comprehensive, but there's a whole bunch of stuff that we've added in since the beginning, and that's been marked as an extension, which can be turned on or off, so it's optional. So a deployer doesn't have to have that feature available. And whenever something comes in, there's kind of a question, should that be an extension or should it be core? If you want it to always be installed everywhere, it's probably core. If it's something people should be able to turn off, they should be able to say, I'm not going to support this, it might be a security risk, it might have performance implications, then it definitely goes in as an extension. And generally, anything that's going to support a vendor proprietary sort of optimization, that almost always comes as an extension. But there's a lot of stuff that you wouldn't think of as an extension. So this is the odd thing for me, right? Key pairs are an extension. The ability to SSH into your server is an extension in Nova that can be turned off.
That's changing.
It's changing? Yes, thank you, Chris. But this was Diablo, and it got better in subsequent times. Better. And this is just Nova, so this doesn't talk about the Neutron set of extensions or Cinder's extensions. Heat's got a kind of different model for tackling it. It's got plugins that you can write locally. Wrong screen, I can't pinch, I'm sorry. Maybe I can, there we go, 90% zoom. What have we done in the last 4 releases? Nothing. We changed everything. Sean had some really, do you remember, Michael, the stats Sean had on code churn?
No.
But we basically touched so much code in OpenStack. I think every release changes 80% of the code or something, just incrementally bits here, there, a bunch of hygiene cleanups, but also people doing refactorings and fixing stuff. You don't know, all right. Please figure it out. You've got, how long? 3 minutes? So I joined the project about just over a year ago now, and in that time I've seen a huge improvement in testing efficiency, but also in sort of less pushback on adding tests and more acceptance of tests are necessary, tests are beneficial, these are the things we get from tests, and expanding the types of tests that we run, how we run them, where we can run them, and third-party testing, which is the current big evolution that's happening at the moment, is bringing another step forward in that. Historically, we haven't had any tests for scaling or performance. I had another project I was involved with that started out that way called Bazaar, and it took a while to turn the performance and scaling aspects of that around, and OpenStack's going down the same curve, right? Joe did a virtualizer driver for Nova, so it didn't actually have a hypervisor there. It just did all of the rest of the logic involved in spinning up a VM. And it found a whole bunch of scaling problems, bang, straight away. So once you get that into the gate, they never come back. So as we test it, we put a ratchet in and we can roll forward. And I think if we go back, and I think back here, if you look at Grizzly and Havana, right, there's 2 new services in there, but there's otherwise pretty much no sort of user visible big ticket items. But we've been doing a huge amount of work on the internals, which is what this is all about. Performance, scalability, reliability, robustness, and a small amount of new features. Oh, and look, there are slides that I didn't need to ad-lib. Right, those. Someone was asking earlier how many block storage, open source storage engines there were. So there's a few. Some of them are open source, some of them are proprietary. Actually, we really should have Tempest in that list back in when it was brought in. So the percentage of code that's unit tested is going up in pretty much every project, except the projects that don't change. No, I'm joking there. Glance has had changes, but it's had much less changes than the rest of the code base in from what I've seen. And here we are, sorry. How long do I have, Michael, seriously?
A minute.
A minute? So there was a small amount of testing, and then there was a lot. So the interesting thing here is that we actually broke stuff, going from Diablo to Havana, we made it better, but we broke reasonable expectations that API clients for Diablo might have. So that's what this slide is talking about. Like we changed an empty list. If for some things, like if you had a bad filter, we'd say, hey, we successfully did your filtering for you and there are no results. And now we give a 400 error. So any client that happened to have a bad filter but that it was doing what the user wanted will now start erroring in their script if they migrate from a Diablo cloud to a Havana cloud. That's, in our definition, an API break. And we didn't mean to break the API. And we can run the current Tempest against the old Diablo and figure this out, which is what's been done here. Critical bugs, okay, there are some numbers, they don't really tell me a lot. The reason they don't tell you a lot is because the adoption of these projects has gone through the roof. Many more users means many more use cases being served, which means many more corner cases being found. The amount of code has increased, so more bugs. If your rate of bugs per line of code stays the same, you'll have more bugs. And our developer base is going up insanely as well. So I find it hard to actually get meaning out of the fact that the numbers went up in one project and down in another. And right, so we've done a bunch of plumbing in the scheduler to try and work around performance problems, and there's another set of iterations going on with that now with Mirantis pushing some pretty cool stuff. We've been doing DB tuning. Michael's been doing a lot of work on making sure that DB migrations themselves are fast, which is a big thing for people who are trying to keep a cloud up and running and migrate the software. And we've got the server script concept we've got is basically broken, and we're trying to figure out what to do with it. So adjusting it and tweaking it is a bit of a workaround, but we need something that's fundamentally better. Optimizations for deployment, that's the image workflow, PKR tokens. Oh yeah, this was one of the really interesting things. So at HP, when we deployed our public cloud, we deployed it on top of Diablo. And that's why I was making a joke before about running on Diablo, because we're not running on Diablo anymore, but we were for a long time because we did over 40,000 lines of code, of changes to the Diablo code base on our own to make it production ready. And I mean, there's been a whole bunch of effort to feed that back up into upstream, and we're now converged. So as it says up there, 2,000 lines of code of management scripts to manage the database for high availability, scaling, tuning it, basically ops tools as I understand it, and then hundreds of hours of tuning as people use it to figure out the problems, add indices, add better queries. And I think most of the G cycle, we were pushing patches as fast as we could, as fast as they'd be accepted to fix that. But a lot of other people were observing the same problems, or they'd even been fixed somewhere in Essex or Folsom.
The database stuff?
Yeah.
A lot of that got pushed up late in Essex and merged in early and middle of Folsom. About 150 indexes were added, a lot of session bugs and race conditions were fixed.
Yeah. But the problem we had was that we had such a big delta in Diablo that migrating was going to be very, very expensive. So essentially we got stuck on Diablo and we backported for a while we were trying to get Trunk to a good condition. And then Havana, we managed to get back and synced up again. And now we're running, about 1,000 lines of code changed, and it's all stuff that's up in patches. I don't think there's anything in the core branches themselves that we run with diffs. We do have plugins to do admin and management with the specific machines we're dealing with and so on.
So do you have any Diablo at all in public cloud anymore?
No.
Nice.
As far as I know. I don't work on the public cloud itself, so I have no idea.
We can probably wrap it up.
Paul, do we have a soundbite for that? No.
It's actually kind of the other way around. The undercloud that runs our public cloud is running mostly on
We don't have the undercloud, overcloud stuff. No, the public cloud itself is on trunk. The deployment methodology we're using is not OO yet. So the undercloud thing is, yeah, that's dead. That's PAS deploy. It's a different thing again. So the services like database as a service that you can also get from the public cloud have Nova as their deployment mechanism. So that's on trunk, but also the public cloud regions. The Bravo region is running trunk. Non-Bravo is not yet running trunk. That's running the release before, but that was, I believe that was brought up to Havana, and then the regions before that were the ones that were Diablo. So the first it was up to Havana, and then it was up to trunk. Don't quote me.
Bet you're on video.
Indeed, and I won't make the smart-ass comment that came to mind when you said that. So we're trying to also make the code easy to maintain code structure, and that's what this forward-facing internal changes means. Make it better from a software practice point of view. Process, is there anything in here we should talk about? Are you guys bored yet?
Yeah, we have to finish.
Okay. So I'm going to keep talking to you as you come up and
Really? That's
hit
such
the...
a lie.
Yeah.
Pushing those away.
You plan.
Everybody thank Robert for his talk.
You're welcome.